All right, so we covered operations when radicals have the same index, but what if they have different indices? So what if we have something like the fourth root of x times the square root of x? We can't just combine these under the same radical, but this isn't considered simplified. Simplified would have just one radical expression instead of two, if we're dealing with just a single term. So what we have to do in these particular questions is that we need to go ahead and convert these to our rational exponents. So we know there's invisible ones on both of our x's, and there's an invisible index of 2 on the square root. So if I wanted to rewrite these as fractional exponents, this is x to the 1/4 times x to the 1/2. And now we have a way to deal with exponents that aren't the same as long as our bases are the same. So in this case, we have the same base, so we can go ahead and combine these under the same radical, because all we need to do is we can go ahead and add these two, right? Our exponent rules tells us if we have x to the m times x to the n, this is just x to the m times, plus n. About to repeat what I had just said. All right, so in this case, we would have x to the 1/4 plus 1/2. And then we just have to do some fraction math, and we would get that x to the 3/4. And if this asks you to express this back as a radical, you could go ahead. Now we have our fourth root of x, and we have an x to the third on the inside of our our fourth root. One thing to be kind of aware of for these problems is you do need to check that the power on the inside is less than our index, right? It might work out that once you do this math that you have to do an additional step of simplifying by bringing an x out in front or something. So just check that we are indeed simplified before you box up your final answer. You can also recognize that essentially, since our power and our index are a fractional exponent, they're essentially a ratio. So if you want to make these things match, you can just do something like that. As long as you're multiplying both the index and the power by the same number, all you're doing is making your 1/2 into 2/4, right? Which is the same exact ratio, same exact value. So then you could never leave your radicals, and you could just be looking at something like this. So now you've made them have the same index without having to convert to fractional exponents and ever using fractions, because now I can just go the fourth root, 1 plus 2 is x third. So just a different way to handle that same problem. Here's one more example. We will try third root of x squared all over the fourth root of x. So take a minute, decide whether you like the idea of making our indices the same or using fractional exponents. I'll do both. So I'm going to try making the indices the same. So I'm just thinking about like almost a common denominator, right? What's the least common factor for these two? So 3 and 4, I need to go all the way to 12. So I need to multiply the third root by 4, which means I need to multiply, the power by 4 as well. Same thing here. There's an invisible one. I'd also need to multiply that by 3. So I could rewrite this as the 12th root of x to the 8th all over the 12th root of x to the 3rd. Now that they have the same index, I can write them all under the same radical symbol, x to the 8th over x to the 3rd, and then I can simplify that to x to the 5th. Now, that's typically not what the books do. The books will always go through those fractional exponents instead. So they would convert this into x to the 2/3, right? Power over index, x to the 1/4, and then use our exponent rules, 2/3 minus 1/4. And then off to the side, we have to painstakingly do some fraction math, because this is why I do it the other way, because I always do everything in my power to avoid fractions. I tell my students I'm an enabler when it comes to fraction avoidance. Okay, so then we could say this is x to the 5/12, and then go back to our radical notation. So 2 ways to tackle those operations when our indices don't match. Last note here, we did multiplication, right? We did division. when we had different indices. We did not do anything with addition or subtraction because there is nothing you can do when you get into this situation. That is as simple as it gets. You can't move any further. Just put a box around it. You're done.